China's Chang'e-6 lunar probe has returned to Earth, bringing with it samples from the unexplored far side of the moon.
China's Chang'e-6 mission uncovered lunar secrets that could completely rewrite our understanding of the moon and Earth's safety. Chang'e-6 returned samples from the moon's far side, revealing chemical anomalies that challenge decades of planetary science and lunar assumptions.
It's a big deal in that this is the first time we will get samples back from the far side of the moon. Prior to this, I can use my little moon, this is the side we see. All of the samples have come from this side. This mission landed on the back side down here, a very difficult place to get to. So it's the first samples from the far side of the moon, but this is the second time China has landed in the far side of the moon, and they're the only country that have done this.
And here's where it gets even stranger. In 2024, China's Chang'e-6 probe made history by landing on the far side of the moon, a place humanity barely glimpsed until now. This wasn't just another touchdown. The far side is a harsh, cratered world, a battlefield of ancient cosmic collisions. Mountains tower over landscapes that haven't felt human presence, and rocks that have been sitting there for billions of years are about to tell their story. Chang'e-6 wasn't alone in curiosity. Scientists meticulously collected samples from this untouched terrain. Every rock, every mineral was carefully studied, knowing it held secrets locked away from earthly eyes. This mission wasn't about planting flags or taking selfies. It was about uncovering history hidden beneath the moon's surface. History that could change how we understand our celestial neighbor forever. But wait, it's about to get way more shocking. We all know the moon's familiar face, the near side with its smooth maria and lava-filled plains. The one that guided sailors, inspired poets, and lit up countless nights. It looks calm, almost serene. But flip it, and the far side tells a completely different story. Picture jagged mountains, deep craters, and landscapes scarred like an ancient battlefield. It's chaotic, raw, untouched. The surface differences alone are startling, but here's the kicker. Chang'e-6 revealed that these contrasts aren't just skin deep. The far side's interior is fundamentally different from the near side. We're talking hundreds of kilometers into the moon's core. This isn't just about appearances. It's about two worlds coexisting in one moon, each with its own violent past. The samples brought back aren't just rocks. They're a time capsule from an era we barely understand, showing us that the moon's story is far more complex and unsettling than anyone imagined. Have you ever seen something that appears calm from one side, yet conceals chaos on the other? That's exactly what Chang'e-6 exposed, and here's the part that blew scientists' minds. The far side mantle? It's in what researchers call a reduced state. In plain terms, it's stripped of oxygen far beyond what physics says should be possible. Imagine rocks that have been sitting there for billions of years, yet somehow underwent chemical processes that defy every known rule of planetary formation. Dr. Yang Wei and his team ran the tests again and again, double-checking, triple-checking their instruments. Nothing was wrong. The far side mantle's chemistry is fundamentally different from the near side, suggesting we're looking at two completely distinct internal worlds inside the same moon. What caused this? Some scientists point to a massive ancient impact, so violent it permanently altered the moon's internal chemistry. Others suggest that the far side contains primitive material, remnants from the very early solar system that never experienced the heating and mixing the rest of the moon went through. Either scenario is mind-blowing. It's a hidden record of extreme events in our cosmic backyard, preserved in rock, waiting billions of years to be discovered. This isn't science fiction. This is real. The moon we thought we knew, the calm, predictable companion in the night sky, is far stranger, far more dangerous, and far more mysterious than we ever imagined. Just when it seemed we had a handle on the moon, Chang'e-6 flipped everything upside down. The samples suggest that the moon didn't just form the way we thought. Current models say it was a relatively straightforward process. Debris from a collision with Theia coalescing into a single, mostly uniform body. But the far side's reduced mantle tells a different story. Something extreme happened, deep inside, billions of years ago, shaping the moon in ways our textbooks never imagined. Scientists are now considering the possibility of a catastrophic event so powerful that it permanently altered the moon's internal chemistry. We're talking shock waves that penetrated far beyond the surface, restructuring the core itself. This isn't minor, it's a cosmic scale disruption, leaving permanent fingerprints in the very heart of the moon. The differences between the near and far sides aren't just cosmetic. They suggest the moon's early history was asymmetric, shaped by violent events in the young solar system. The far side might have borne the brunt of these early cosmic battles, while the near side remained relatively protected. Chang 6 has given us proof that the moon isn't just a passive companion, it's a survivor of chaos, carrying scars from events that we're only beginning to understand. Have you ever thought that the calm moon staring down at us might have survived something almost unimaginable? That's exactly what these samples are whispering, and here's where things get terrifying. The energy required to strip oxygen from the far side mantle? Think of millions of nuclear bombs detonating at once, but focused on one hemisphere. That's the scale we're talking about. It's not just wild speculation. The chemical fingerprints in the rocks demand a level of energy that ordinary impacts could never create. Some scientists believe this could have been a single, planet-altering collision. Others argue for multiple massive impacts over millions of years. Either way, it explains why the moon's near side and far side look and behave so differently. The far side is scarred, reduced, and chemically altered, while the near side remains relatively stable. But it doesn't stop there. If events this violent happened in our cosmic backyard once, what's stopping them from happening again? The solar system isn't empty. It's a shooting gallery of asteroids, comets, and other rogue objects. And if something like this struck the moon again, the implications for Earth's stability are staggering. We rely on the moon to stabilize our planet's rotation, influence tides, and buffer impacts. A destabilized moon could have ripple effects straight to us. This isn't a sci-fi movie, it's reality encoded in rock. And Chang 6 brought it home in a way that every space scientist now has to take seriously. But wait, there's another possibility that makes this even more unsettling. Some researchers think the far side mantle isn't just reduced, it might contain primitive material predating the moon itself. Let us take to the moon and rocks that have not been touched for over 4.6 billion years and came from the very solar nebula, which was the mother of our entire solar system. These are not just any lunar rocks. They are fossils from the dawn of the universe lying in the pristine state of being, never melted, mixed, or changed. If so, then the places on the moon where these samples are taken from are the oldest and the most original material ever studied. This gives the researchers a direct passage to the solar system formation, revealing how some matter went through billions of years of chaos and collisions and still got to remain intact. However, there is a drawback. Primitive matter like this could respond differently to stress or heat, thus causing subtle instabilities in the moon's interior. That might be the reason for slight changes in its orbital mechanics we have detected, very small changes in the moon's distance from Earth over time that are not fully explained by the prevailing models. Simply put, the moon's secret interior, which has been trapped for millions of years, is not only a historical account, but also a potential source of influence on the Earth's gravitational stability and orbital patterns. Moreover, Chang 6 has provided us with the first real evidence that our comprehension of planetary formation and the moon itself is much less than complete. And here's something that really makes you pause. The far side's reduced mantle isn't just a quirky chemical anomaly. This is a hint that the moon could be geologically active in ways we have never even considered. The removal of oxygen from deep-seated lunar rocks brings about a change in the chemical reactions that take place inside the moon. These reactions might still be happening, slowly and subtly, so the melting of the moon's interior is taking place over a long period of time. The situation is no different for Earth. The moon, through its gravitational pull, plays a vital role in the Earth's rotational stability and tidal formation. If the far side's internal activity is behind the moon's orbit, then it could have an effect on Earth's tides, ocean currents, and the length of our days. Some researchers suggest that this might even be the reason behind the tiny but detectable changes in the moon's distance from Earth that the existing physics models cannot explain. The moon was our stable, predictable neighbor for a long time, but Chang'e 6 is now indicating that this assumption might be highly risky. Our celestial satellite is not merely a rock with no life. It is a living witness of violent events, a place where internal chemistry is perpetually going on, and a potential factor that could upset Earth's long-term stability. The world's scientific community is buzzing. China's decision to share Chang'e 6 samples internationally has turned the moon's far side into a global research hotspot. Scientists everywhere are poring over these rocks, fascinated but also deeply concerned. This isn't just a Chinese achievement, it's a planetary wake-up call. Debates are raging. Was the reduced mantle created by a catastrophic impact, or does it contain primitive material predating the moon? Every new paper adds more questions than answers. Researchers are now forced to reconsider assumptions about the moon and the solar system on a fundamental level. This isn't just academic. The discovery has real implications for Earth's long-term stability and how humanity approaches space exploration. The moon's hidden secrets remind us that our solar system is far more dynamic and potentially dangerous than we ever thought. And here's where science meets engineering. The Chang'e 6 samples are not only for scientific writing, but also for determining the characteristics of life on planets other than the Earth. Lunar soil could lead to oxygen, water, and even settlements made from the very ground where they stand. But this new mindset is already being reflected in the engineering world. The moon's reduced state of the mantle has made it harder to access resources underground. Areas previously thought to be the best for mining might be chemically different or even unstable, thus making the whole process of extracting and building far more complicated than previously anticipated. Permanent colonies might be exposed to geological risks caused by internal activity that has not been considered. Minor earthquakes or internal chemical reactions may change the local gravity, making the buildings collapse or causing the systems to fail. This situation leads the mission's planners to reconsider the design of colonies, the location of filters, and the selectivity of measures required for safety. Further missions would need to use highly advanced analytical tools to investigate the subsurface thoroughly before any long-term installations are made. Contingency planning has become not only an option, but a necessity. The moon is not an object that can be used only for the sake of resources or the purpose of stepping to Mars. It is a complex and possibly unstable world that has to be completely understood before mankind can start expanding safely. Every move we make now must take into consideration the truth that Chang'e 6 has presented. The interior of the moon is not only ancient, but also full of secrets that can influence our future in space. So how does this affect the forthcoming lunar exploration wave? There is urgency to map out the distribution of the reduced mantle material on the far side of the moon to comprehend the situation better. A mere landing, collecting samples, and departing would not suffice. The moon's interior has to be characterized in terms of stability before habitation is allowed. Multiple sites across the far side will have to be studied to get a full picture. Every crater, every lava flow, every ridge could tell a different story about the moon's chemical and geological history. This makes future missions far more complex and expensive. Engineering challenges are mounting. Landing zones must be carefully chosen, resources carefully assessed, and permanent installations designed to withstand unknown geological activity. Contingency plans for unexpected chemical or seismic events will be critical. All this means humanity's long-term expansion beyond Earth might be delayed by years, maybe even decades. Chang'e 6 has proven that the moon is more than a stepping stone. It's a puzzle, a warning, and a frontier we must approach with caution, curiosity, and respect. And now the stakes go beyond lunar science. The moon isn't just a pretty face in the night sky, it's Earth's cosmic shield. Its gravity deflects asteroids, stabilizes tides, and keeps our planet's rotation steady. But if the moon's interior is unstable, as Chang'e 6 suggests, that protective role might not be as reliable as we've always assumed. And as we look toward Mars and beyond, these revelations demand caution, curiosity, and bold planning. Humanity's future depends on understanding the full story of our closest celestial companion. The Chang'e 6 mission has rewritten what we know about the moon and raised unsettling questions about Earth's safety. From reduced mantle states to primitive material, humanity's next steps in space must account for a moon that's more mysterious and potentially more dangerous than ever before.